Hello everyone, in this video we are starting off with a new chapter called Polynomials. So in earlier classes you must have studied polynomials in one variable and about their degrees as well. So we normally represent a polynomial in one variable as f of x. Let me use a different color. F of x, g of x, capital F of x, or capital G of x. Alright, so this polynomial is a representation of polynomial in one variable. This is the representation of polynomial in one variable, that is the variable x. Suppose say the polynomial is of variable y, we then represent it as f of y, g of y, capital F of y, or capital G of y. Alright, so let's try and move into the term degree. I'm moving to the next slide. So basically let's see a few examples of polynomials. Alright, the first example is 3x plus 4. Alright, so here the degree of the variable is 1. Alright, 1. So let's try and understand what degree is. Degree is going to be the highest power of the variable that is present. So here it is 1. Alright, so x is equal to x power 1. That's why I've written it as x. So here it is 1, and hence the degree is equal to 1. Similarly, let's see the second example, which is 3x squared plus 4x plus 5. Alright, so this is again a polynomial. Here if you see, the degree is going to be 2. Although there are x is present 2 times, x has a degree 1 and it has 2 as well. Here the degree will be 2. Degree of x will be 2. So let's move on to the other example. The third example being my cube plus ny squared plus py plus 8. So there's nothing much special about this particular equation, but if you watch here, m, n and p are constants. What are the variables here? Y is the only variable. So if you see, look at y is present 3 times in this particular equation. But what is the degree of the equation? If you ask me what is the degree, it is 3. Because degree, as we saw, is the highest power of the variable that is present in the polynomial. Alright, so yeah, and there's another important note. Alright, so expressions such as 1 by x squared minus 1 and 3 root x minus 8 are not polynomials. Alright, because polynomial always depends on the degree of the variable. So here if you see the degree of the variable, so this particular expression can be written as x squared minus 1 the whole power minus 1. Alright, but polynomials are defined only for positive integers. That is, let me go to another slide. So here if we see, so polynomials are only defined for positive integers, that is from 1, 2, 3, 4 and so on. And let's try and understand polynomials with the help of 3 more examples. Let me draw a tabular column here. So yeah, so the first one is 8x plus 5. The second one is 3x squared plus 4x plus 7, and the third one being square root of 8 y cube plus 4y squared plus 9. So if you look at the first equation, alright, so this has the degree 1. If you look at the second one, this has the degree 2. This has a degree in the sense the variable x has a degree 2. If you look at the third equation, the variable y has a degree 3. Carefully note that here square root is for 8, alright. So it's not there for y. If y has a square root, that case you can't call it a polynomial. Even in that case, if you have the highest degree, that is the highest power of y equal to a positive integer, then it can be termed as a polynomial. Here it is a polynomial. Please don't get confused with the previous example. So this is a polynomial of in variable y of degree 3. So now let's look at the different types of polynomials. That is the 3 most common polynomials. Suppose say if the degree, let me write it here. So this is the degree and this is the polynomial itself. Suppose say the degree is 1. Degree of the polynomial is 1. What do I call the polynomial as? So a polynomial with degree 1 is called as a linear polynomial. Linear polynomial. And a polynomial with a degree 2 is called quadratic polynomial. Let me go to the other slide. So polynomials, I'm writing the classification here, alright. Polynomials, I'm sorry, yeah, polynomials so here if degree equal to 1, then we call it a linear polynomial. If degree equal to 2, then we call it a quadratic polynomial. If the degree is equal to 3, we then call it a cubic polynomial, alright? Cubic polynomial, yes. So now that we are quite clear with the type of polynomials, let's move to another example. Yeah, here comes an example. Let's try and solve this question. A polynomial is given, is of the form f of x equal to 2x squared plus 3x plus 8. So find the value of, so the question goes like this, alright. Find f of x when x equal to 2. So what do you do here? This is nothing but a simple substitution. Wherever you find x, you just have to take this 2 and plug in the value of 2 here. Alright, so here it will be, the equation would become f of 2 equal to 2 into 2 squared plus 3 into 2 plus 8, which is nothing but 2 into 4, correct, plus 3 into 2, which is 6, plus 8. So the final answer is 8 plus 8 plus 6, which is nothing but 22. If you see, 8 plus 6 gives me 14 and 14 plus 8 gives me 22. And let's solve another simple example. So the question is given as if f of x equal to 2x squared plus x minus 6, alright, then find f of x when x equal to -2. So here again, this is nothing but a simple substitution. Let's try and plug in the value of -2 in this equation. Right. That case, we will have f of -2 equal to 2 into -2 squared plus -2 plus of -2. X is equal to -2 here. -6. So we have 2 into -2. The whole square is nothing but +4. Minus into minus is +4. Plus of -2 is minus. Minus into plus is minus. So -2, -6. So here if we see the answer, 2 into 4 is 8. 8 minus 2 minus 6. And the answer is 0. So 8 minus 2 gives me 6. 6 minus 6 gives me 0. Let's try and solve one more problem. Yeah. So this question says if f of x equal to x squared plus 7x plus 10, then find f of 5. Here they've just reframed this question slightly. Here in the previous questions, if you see, they must have told you find f of x when x was equal to 5. Here they have, so when we have this question, we simply plugged in the value of 5 in this particular equation wherever we found x. So that equation became f of 5 equal to 5 squared plus 7 into 5 plus 10. Here they have directly mentioned that find f of 5. So here again, wherever we find the variable x, we will just plug in the value of 5. In that case, the above equation becomes f of 5 equal to 5 squared plus 7 into 5 plus 10. Correct. So this is nothing but 25 plus 35 plus 10. So now tell me, what is this value? We have 25 plus 35 equals 60 plus 10. 60 plus 10 is nothing but 70. Alright. So this is all about this video. Thank you for watching.